Welcome back to our ongoing exploration of a fascinating world of mathematics. Today, we're taking a deep dive into a truly mind-bending concept,
Yeah.
the mathematical universe hypothesis, or MUH, as proposed by cosmologist Max Tegmark.
Right.
What if instead of just describing the universe, mathematics actually is the universe?
It's a pretty radical idea. Physicists are always searching for a theory of everything,
Right.
a single framework to explain all forces and particles. The MUH aims to do just that, but with a twist.
Okay.
It suggests that the universe isn't just described by math, but that it fundamentally is a mathematical structure.
So it's not that math is a useful tool, it's that reality itself is built from mathematical stuff.
Exactly.
That's a huge shift in perspective.
To use an analogy, think of a computer game.
Okay.
We see characters, objects, a world, but underlying it all is code.
Right.
Tegmark saying the universe is like that. The code, the math is the fundamental reality.
And we're like the characters experiencing this reality through our limited senses.
Exactly.
Didn't Tegmark also propose different levels of multiverses?
He did.
Where does the MUH fit into that?
You're right, he did. He proposed 4 levels, and the MUH represents the most extreme level 4.
Okay.
The first 3 levels deal with variations on our known laws of physics,
Okay.
different starting points for the universe, different values for physical constants. But level 4
Okay.
suggests entirely different mathematical structures, each a universe with its own unique set of rules.
Wow.
We've discussed some of those other levels in previous deep dives, and they're definitely worth exploring further.
It's mind-boggling to think there could be universes where the laws of physics, as we know them, don't even apply. Now, on top of the MUH,
Yeah.
Tegmark also proposed the Computable Universe Hypothesis, or CUH.
Right.
What's that about?
The CUH takes the MUH a step further
Okay.
and suggests that the mathematical structure of our universe is defined by computable functions. Essentially, the universe is like a giant computer program
Oh, wow.
running on a set of instructions.
So everything that happens from galaxies forming to me making a cup of coffee,
Yeah.
it's all just the output of some cosmic algorithm.
That's the idea, though. It's important to remember it's still a hypothesis.
Right.
But it does raise some fascinating questions about the nature of reality and free will, doesn't it?
It certainly does. A universe made of math.
Yeah.
That's a big claim. I'm guessing not everyone agrees with Tegmark on this.
You're right.
What are some of the biggest criticisms leveled at the MUH?
You're right. The MUH is a bold idea, and like any bold idea, it has its share of critics. One major challenge comes from Gödel's incompleteness theorem.
Okay.
It states that within any sufficiently complex mathematical system, there will always be statements that are true but can't be proven within that system.
Interesting.
This creates a problem for the MUH because if the universe is a mathematical structure, shouldn't it be able to completely describe itself?
So how does Tegmark address this challenge?
He argues that only those mathematical structures that are Gödel complete, meaning they can prove all their true statements, actually have physical existence. This limits the scope of the MUH to a smaller subset of mathematical structures, but it also might explain why our universe seems relatively simple compared to the vast landscape of mathematical possibilities.
That's a clever way to address the issue. But can we even test the MUH?
Right.
Can we actually prove or disprove something this grand?
That's another big point of contention.
Yeah.
Some critics argue that the MUH is untestable, that it's more philosophy than science.
Right.
But Tegmark argues that the MUH does make predictions.
Okay.
For example, it predicts that as we explore the universe further, we'll continue to find mathematical regularities in nature.
It seems like a central question here is whether math is an invention or a discovery.
Absolutely.
If math is an external reality independent of human minds, then the MUH becomes much more plausible. But if math is just a tool we created, then the whole idea starts to crumble, right?
Exactly. This gets to the heart of the debate over what's called radical Platonism.
Right.
Is mathematics an inherent feature of reality discovered by us, or is it a human construct we've imposed on the world?
Right.
Thinkers like Don Page and Brian Greene have argued both sides of this, adding even more depth to the discussion.
This is already such a thought-provoking deep dive. But we're just getting started.
It is.
We'll continue our explorations of the mathematical universe hypothesis and its implications after a quick break.
Sounds good.
So we've talked about some of the challenges to the MUH, but let's flip the script. If we entertain the possibility that Tegmark is right, what are some of the mind-blowing implications of a mathematical universe?
Well, for one, it suggests a deep and beautiful underlying order to reality. If everything is ultimately mathematical, then the universe isn't just a random collection of stuff.
Right.
It's an elegant and intricate structure.
It's like we're living in a giant equation waiting to be solved.
Yeah,
But doesn't that raise questions about free will?
it does.
If everything is determined by mathematical laws, do we really have any choices?
That's a huge question that philosophers have been wrestling with for centuries. The MUH certainly adds a new layer of complexity to the debate. Does a mathematical universe equal a deterministic one? It's not a simple answer.
And what about the search for extraterrestrial life? Does
Right.
the MUH have any bearing on that?
Absolutely. If the MUH is true, then the possibilities for life in the universe become truly vast. We might find life forms in other mathematical universes, perhaps based on entirely different principles than life on Earth. Imagine a universe where the building blocks of life aren't carbon-based, but something completely different.
It's incredible to think that we may not be alone, even if those other life forms exist in realms with vastly different physics than our own. But if the MUH is correct, could we even comprehend what these other universes are like? If their fundamental laws are different, wouldn't they be completely beyond our imagination?
That's a very real possibility. Our understanding of reality is shaped by our experiences within this particular universe. Trying to imagine a universe with different mathematical foundations might be like trying to describe color to someone born blind.
It's a humbling thought. But maybe, just maybe, mathematics itself is the key. Maybe it's the universal language that allows us to glimpse these other realities, even if we can't fully grasp them.
That's a beautiful and thought-provoking idea. Mathematics might be the bridge that connects us to the infinite diversity of the mathematical multiverse.
Okay, before we get too carried away with imagining alien civilizations based on non-carbon-based life, let's bring things back down to Earth. If the universe really is fundamentally mathematical, does that change how we do science?
It certainly challenges our traditional notions of observation and experimentation. If there are other mathematical universes out there, how could we ever interact with them or even detect their presence? It might require us to develop entirely new ways of thinking about scientific inquiry.
Perhaps we need to broaden our definition of evidence beyond just empirical data from our own universe. Could mathematical proofs and logical deductions also count as evidence for the existence of these other realms?
That's an intriguing question and one that could potentially revolutionize the scientific method as we know it. It also brings us back to that fundamental question of whether math is an invention or a discovery. If the universe is truly mathematical, then perhaps the line between physics and mathematics is much blurrier than we currently think.
This deep dive is really making me rethink some fundamental assumptions about the universe and our place in it. We've covered a lot of ground, but there's still so much to unpack.
There's always more to explore, and that's the beauty of it all. The MEH may not give us all the answers, but it certainly opens up a universe of new questions.
So as we wrap up this part of our deep dive into the mathematical universe hypothesis, I want to leave our listeners with a challenge. If the universe really is made of math, what does that tell us about our own potential as humans?
Are we just complex algorithms running on a cosmic computer, or is there something more to our existence?
Could a deeper understanding of the mathematical underpinnings of reality lead us to unlock new levels of creativity, innovation, and perhaps even consciousness itself?
It's a question worth pondering as we continue our exploration of this vast and mysterious mathematical universe.
We've been diving deep into some pretty profound concepts today,
Yeah.
exploring the idea that our universe might not just be described by math, but actually be math.
Right.
It's certainly a mind-bending idea, and it raises as many questions as it answers.
That's the hallmark of any truly fascinating theory. It pushes us to reconsider our assumptions
Right,
and to look at the world in a new light.
exactly. And the mathematical universe hypothesis, while still very much a hypothesis,
Right.
forces us to confront some really big questions, like if the universe is fundamentally mathematical,
Yeah.
what does that tell us about the nature of reality itself?
It suggests that there's an inherent order and beauty to existence, even if we don't always perceive it. It implies that there might be a deep underlying structure to everything we experience.
And it raises intriguing possibilities about other universes,
Yeah.
perhaps with different mathematical foundations,
Right.
governed by laws of physics that are completely alien to us.
It makes you wonder what kinds of incredible things might exist out there beyond the limits of our current understanding. Perhaps there are universes where time flows differently or where gravity works in reverse.
The possibilities are truly endless. But even if we never get to explore those other mathematical universes, just contemplating their existence
Right.
expands our horizons and challenges us to think bigger.
It reminds us that there's always more to learn, more to discover, and that the universe is far more complex and mysterious than we can possibly imagine.
Exactly. And while the MUH may not be the definitive answer to all our questions about the cosmos,
Yeah.
it certainly provides a framework for thinking about those questions in new and exciting ways.
It encourages us to look for the underlying mathematical patterns in everything from the smallest subatomic particles to the largest cosmic structures.
And maybe, just maybe, by understanding those patterns,
Yeah.
we can unlock deeper truths about the nature of reality and our place within it. Perhaps math is the key to unlocking the secrets of the universe.
Who knows what we might discover if we keep exploring, keep questioning, and keep pushing the boundaries of human knowledge.
Well said. I think that's a perfect note to end on. So to all our listeners out there, we encourage you to continue pondering the mysteries of the mathematical universe hypothesis. Keep exploring, keep questioning, and never stop seeking the beauty and wonder that lie hidden within the fabric of reality. Thanks for joining us on this deep dive.